absence of gravity, known as microgravity, affects astronauts on Mars missions? Microgravity is a fascinating concept. It refers to the condition in which people or objects appear to be weightless. The effects can be seen when astronauts and objects float in space. Microgravity is not about the total absence of gravity, as some might believe. Instead, it's about experiencing gravity differently. How does this tie into Mars missions, you may ask? Well, the effects of microgravity are a crucial consideration for astronauts venturing to Mars. It's not just about floating around in a cool spaceship, it's about the physiological and psychological changes that can occur in a microgravity environment. Microgravity can affect everything from an astronaut's physical health to their mental well-being. This makes understanding and preparing for it a crucial part of mission planning. That's enough of an introduction, I think. Let's dive right into our countdown, starting with number 10. At number 10, we have the physical changes that astronauts undergo due to microgravity. The absence of gravity's pull in space leads to a host of unique physical alterations. Our bodies, so accustomed to the constant tug of Earth's gravity, begin to adapt to this new environment in surprising ways. Firstly, muscle atrophy becomes a concern as our muscles, no longer needed to fight against gravity, begin to weaken and shrink. This can occur in as little as 72 hours and affects all muscles, including the heart. Next, bone density loss kicks in. Astronauts can lose up to 1.5% of bone mass per month in space, particularly from the lower body and spine. This is similar to the rate of bone loss seen in postmenopausal women. Lastly, fluid redistribution takes place. Without gravity pulling fluids down, they tend to accumulate in the upper body, leading to a puffy face and skinny legs, a condition affectionately known as bird leg among astronauts. Next on our countdown, we'll explore how we're combating these effects. Coming in at number 9, the countermeasures developed to fight the physical changes in microgravity. In the face of muscle atrophy and bone density loss, astronauts are not left to fend for themselves. In fact, they are equipped with a variety of tools and techniques to keep them fit and healthy. Exercise is their first line of defense. Astronauts typically spend around 2 hours each day working out using specially designed equipment that's adapted to the weightless environment of space. From treadmills with harnesses to resistance devices, they use these tools to stimulate muscle use and prevent bone loss. Alongside exercise, astronauts also follow a carefully calibrated diet to ensure they get the right nutrients to maintain their health. With these measures in place, our brave space explorers are able to keep the adverse effects of microgravity at bay. Moving on to number 8, let's see how microgravity affects the mind. Number 8 brings us to the psychological impacts of living in a microgravity environment. The human mind is a complex entity, not designed to exist in the cold vacuum of space. Astronauts, regardless of their physical fitness, are not immune to the mental and emotional challenges of long-term space travel. Isolation from loved ones, confinement within a spacecraft, and the constant looming threat of danger can take a toll. Furthermore, the lack of day-night cycle and the disorienting effects of microgravity can disrupt sleep patterns and lead to chronic fatigue. Prolonged exposure to such conditions can lead to stress, anxiety, and even depression. We're talking serious space blues here, folks. But it's not all doom and gloom. Astronauts are trained to handle these issues, and space agencies are constantly developing new strategies to maintain psychological well-being. Next, we'll take a look at how we're preparing for these psychological challenges. At number 7, we have the strategies being developed to maintain astronauts' mental health during Mars missions. The journey to Mars is long and isolating, making mental health a paramount concern. Effective communication is the first strategy on our list. Regular and meaningful exchanges with mission control and loved ones back on Earth can provide a sense of connection and reduce feelings of isolation. Next, we have recreation. Yes, even in space, astronauts need downtime. Engaging in enjoyable activities can provide a much-needed mental break and maintain morale. This could be as simple as reading a favorite book or watching a movie. Lastly, stress management is key. This can be achieved through various means, from mindfulness and meditation to physical exercise. Implementing these strategies can help astronauts stay mentally fit, ensuring they're ready to face the challenges that come with living in an environment like Mars. Up next, we'll delve into the effects of microgravity on biological processes. Number 6 on our countdown involves the intriguing effects of microgravity on biological processes. Imagine being in a place where up and down have no meaning, where your body floats freely. That's the reality for astronauts in space, and it has a profound impact on their biological processes. For starters, microgravity affects the immune system. In space, the body's defense system can become compromised, making astronauts more susceptible to infections. Now think about the cells in your body. In microgravity, they behave differently. For example, red blood cells, which are typically round, can become elongated in space. Moreover, microgravity can affect bone density and muscle mass. Without the constant pull of gravity, bones can lose density and muscles can atrophy. These changes pose significant challenges for long-term space travel, like a potential mission to Mars. Let's move on to number 5, where we'll discuss the research being done to understand these effects. At number 5, we have the ongoing research into the effects of microgravity. This research is a fascinating blend of biology, physics, and psychology, all aimed at unraveling the mysteries of how our bodies and minds react to the absence of gravity. Scientists around the globe are conducting experiments in ground-based labs and aboard the International Space Station, using cutting-edge technology to monitor astronauts' physical and mental health in real time. They're studying everything from muscle loss and bone density to cognitive function and mood changes. What's more, they're not just looking at the immediate effects, but also the long-term ramifications of spending extended periods in a microgravity environment. This work is crucial in helping us better understand the potential health risks and develop effective countermeasures for future space travelers. Coming up, we'll look at how all this research is shaping our plans for Mars missions. Number 4 on our countdown is all about how we're preparing for Mars missions. The Red Planet is our next frontier, a destination that has sparked our curiosity and fueled our imagination. As we inch closer to making this dream a reality, our understanding of microgravity plays a pivotal role. This knowledge is instrumental in planning and training for these missions. Imagine engineers designing spacecraft and suits that can withstand the rigors of a microgravity environment. Or think about astronauts fine-tuning their physical and mental health strategies to counteract the effects of living in such conditions for extended periods. From the launch pad to the Martian surface, every aspect of the mission is influenced by our understanding of microgravity. Our aim? To ensure the safety and success of future Mars explorers. The lessons we've learned from microgravity research are guiding us as we prepare to take humanity's next giant leap. Next, we'll look at the potential challenges we might face on Mars due to microgravity. Coming in at number 3, we have the potential challenges on Mars due to microgravity. So, what are these challenges exactly? Well, after spending months in the weightlessness of space, astronauts will have to adjust to the gravity of Mars, which is only about 38% of Earth's gravity. Imagine suddenly feeling lighter, yet your body still has to work harder to move around. This can lead to a range of issues. There might be problems with balance and coordination, making even simple tasks difficult. Our astronauts could experience muscle weakness and skeletal changes, similar to osteoporosis here on Earth. And let's not forget about the potential difficulties with the circulatory system, as the heart adapts to pumping blood in a different gravitational environment. All these factors make living and working on Mars a real challenge. But don't lose heart, because as daunting as these issues may seem, they're nothing that human ingenuity and perseverance can't tackle. Next on our countdown, we'll look at how we're preparing to overcome these challenges. Number 2 on our countdown is all about how we're planning to overcome the challenges of microgravity on Mars. The Red Planet, with its gravity only 38% of Earth's, presents a unique set of obstacles, especially for astronauts coming from long-term space travel. To tackle these challenges, a plethora of strategies and technologies are being developed. These include comprehensive physical therapy protocols designed to help astronauts regain their earthly strength, as well as advanced exoskeleton suits that can assist in acclimatizing to Mars's gravity. Moreover, scientists are exploring the fascinating world of artificial gravity. By simulating Earth-like gravity conditions during the journey, we can potentially reduce the physical toll of space travel on our astronauts. In addition, we're also exploring ways to adapt our spacecraft and habitats on Mars to better accommodate the lower gravity. In the ongoing quest to conquer the final frontier, these strategies represent our best bet yet for overcoming the challenges that await us on Mars. Finally, the moment you've all been waiting for, number 1 on our countdown. And finally, at number 1, we have the future of Mars missions. As we delve deeper into the 21st century, the exploration of Mars continues to pique our collective curiosity. Our understanding of microgravity, coupled with technological advancements, is setting the stage for more sophisticated and ambitious missions to the Red Planet. Future plans involve not only sending more robotic explorers, but also preparing for the day when humans first set foot on Martian soil. These missions will push the boundaries of our knowledge and capabilities. And as we keep learning about the effects of microgravity, we'll continue to refine our strategies and technologies to ensure the safety and success of these groundbreaking expeditions. The journey to Mars is a testament to human ingenuity and resilience. It demonstrates our unyielding desire to explore the unknown and expand the boundaries of our existence. And there you have it, the top 10 things you need to know about microgravity and Mars missions. Thanks for watching.